Remember, in this unit, we've been talking about rational expressions, how to reduce them, how to state non-permissible values for them, how to add them, how to subtract them, how to multiply them, and how to divide them. Okay? And they've been all rational expressions. The last thing we're going to look at is rational equations. Who can tell me the difference between an expression and an equation? What's that? For what? Okay. So can you give me an example of a rational expression? What's that? That's not rational. We've been doing them in the first three. Okay, give me one with a variable in it. -4/x.
3x/8.
3x/8. Okay. So that's an expression. What would be an equation? Exactly. As soon as it equals something else, it now becomes an equation. Remember the difference between the two. Okay? For expressions, we don't solve expressions. We simplify them and then evaluate them if you're told what x is. So if this wasn't here, okay, and if I told you, well, we can't simplify this, okay, we can't reduce it, there's no fractions to add or subtract or multiply or divide. The only thing I could do is evaluate it, but in order to evaluate it, I have to tell you what x is, right? So what if x is 2? Evaluate this expression if x is 2. -2, because -4 divided -2 is, or sorry, -4 divided 2 is -2. Okay? We solve equations. Okay? When we talk about solving things in math, we're talking about solving equations. Okay, so a rational equation. Well, it's an equation that contains at least one rational expression. And remember, we decided to define a rational expression. It's like a fraction, an algebraic fraction. So a couple of examples, like we've got one up here, -4/x equals 5. We could do long ones like 1/x² minus 9 plus 7/x equals -2. Okay, those are all examples. And like I said, we solve them. Okay? So how do we solve these things? Because some of them are going to look pretty big. First thing we do, make sure all the denominators are factored. If you can. Remember, we did that with a lot of rational expressions when we were doing the operations. If you can. Then what we're going to have to do just like we did with a lot of rational expressions, Gideon, state all non-permissible values, or NPVs. Then we actually go ahead and solve the equation. Well, how are we going to solve the equation? We are going to clear all the fractions, meaning make them non-fractions. And we did very simple rational equations back in grade 9 and grade 10 by multiplying by the lowest common denominator. By multiplying by the, and I'm just going to put LCD, lowest common denominator. Once the fractions are all gone, it becomes a much easier equation to solve. So once those are all gone, then we solve what's left. Okay. And then finally, we get our solutions, but we've got to check to make sure our solution, or there could be more than one. One thing that we've done in grade 11 this year when solving equations, we've been solving a lot of equations where there's been more than one answer. So we need to make sure they are not NPVs. Because if it is, it's not a solution. It can't work. And I already talked about this at the beginning. Okay, we simplify rational expressions. But we solve rational equations. So remember, if we had, say, something like this, 1 over x plus 3 over x squared. That's an expression. We would simplify it by finding the LCD and combine them, right? Okay. So our answer would be a fraction, wouldn't it? Okay. But if it's this, we are trying to clear the fractions out. Our answer is not going to be a fraction. Well, it could be a fraction number, but here the denominator is going to stay. Here we want to get rid of the denominators so we can find out what x is. Okay, that's the big difference between the two. So this, remember, expression equation. Like I said, we've solved these ones before. It's just you've never seen variables in the denominator. That's all. So like here, we don't have to write this down. But if I give you this is like from grade. 3x over 4 plus 1 over 3 equals -1. Those are rational equations. You guys have been solving them. But these ones, the denominators were always numbers. What would you do to start solving this? Yes? And then do what? So I'm going to multiply everything in this equation by
because the lowest common denominator of 4 and 3 is 12. And remember, even the non-fractions. And remember, 12 divided 4, that's 3, so 3 times 3x is 9x. 12 divided 3 is the same as 4 times 1 is the same as 4. 12 times -1 is the same as -12.
Notice we cleared the fractions. That's what multiplying by the LCD does.
And it gives us an equation that we've been solving for a long time. So subtract 4 from both sides. Divide both sides by 9 to get your final answer.
Okay? Like I said, those are from, we did a lot of those in grade 9. We did some in grade 10. Okay? Now we're just going to look a little bigger. Okay. So, you guys know how to find LCDs of variables. First of all, before I do that though, remember the steps. Do I have to factor any denominators? Can anything be factored? No. No, there's nothing you can factor. Okay? Therefore, we have to state the NPVs or NPV. What would the non-permissible value be in this one? A can't be 0. Because if A is 0, that's going to become undefined, that's going to become undefined, and we can't solve it. Now, multiply by the LCD. What is the lowest common denominator of A, 2, and 5A? 10A. Exactly. Because remember, find the LCD of 5 and 2, which is 10. But because there's A's in the denominator, there has to be an A in the LCD. So now we do this. Everything gets multiplied by, 10A. A times 2 plus 10A times 3 over 5A. And then we do the same reducing that I showed you when we did that rational equation with just the numbers in the denominator. 10A divided A is, what's 10A divided A? 10. And I've got a times 4. So 40. 10A divided 2. 5A. Times 1 is still 5A. 10A divided 5A. 2. And I have to times it by 3. Now I've got a very simple equation left to solve. Okay? So we've got the A on the right, so I'm going to move the 6 over to the left side by subtracting sides by 6. And then I can divide both sides by 5 to get 34 over 5. Is that solution okay, or is it a non-permissible value? It's okay. Remember, it can't work out to 0. This didn't work out to 0, so it's good. Okay. The next one, remember, when you've got more than one term, what I suggested, put parentheses around them to remind them that they have to stay together. Do I have to factor any denominators? Nope. So I can go ahead and state the NPVs, because this time it's going to be 2 of them. 2 and 1. What's the LCD?
When you've got binomials like this, the way to find the LCD is just to multiply them together.
So you can see these are gonna get a little big.
So when I show my next step, I've got to go x minus 2 times x minus 1 times the first fraction equals x minus 2 times x minus 1 times the second fraction. Like so. And we're going to see that things cancel. The denominators are going to cancel out. What can I cancel out from here and here? Right. And here and here? Right. So now be careful here because you're left with x minus 1 times 5. So I got to multiply the 5 by both of these. 5x minus 5. What would the right side work out to after multiplying? 4x minus 8.
And now we've got a simple equation left to solve. First of all, we got to get the variables together. So I'm going to move this 4x by subtracting 4x over here.
So I get x minus 5 equals negative 8. Add 5 to both sides. X equals negative 3.
Is that okay? Check it against the NPVs. It's okay. It just couldn't work out to 2 or 1. So we're getting the hang of this? Okay. Like I said, some of them, they're going to get a little big. Okay? I would like you guys to try C.
Then no solution. I want you guys to give C a shot.
See if you can do it. Nothing to factor, NPV or NPVs.
And you're going to multiply everything by x minus 1. You don't have to state the LCD. You can just go straight into the setting. But remember, it's everything. So when you do that, if you do it all correctly, those cancel, you're left with 7x. X minus 1 times 5, I have to multiply both of them by 5 to get 5x minus 5. And these also work out to just 7. Well, I can simplify them right. 7x equals 12x minus 5. Take the 12x over, so it becomes negative 5x equals negative 5. Divide both sides by negative 5, and I get x equals 1.
Yes? Does anybody want to add to that? No solution.
Because it's an NPV. No solution.
So that's what you got to watch out for. With rational equations, you always have to check your solutions against the NPVs. Let's do a couple more on this page.
Okay. Any factoring to do? Nope. NPV? 0. This one, I'm going to multiply everything by 4x. Four x divided 4. X times x. Four x divided x. 4. And then times 7 equals 12x.
Now what? What kind of equation is this? Quadratic, baby. That means we got to factor it to solve, or we got to use the quadratic formula. But we got to bring everything. Yeah, with most of these, I can tell you, it's the you'd be able to factor them. Because quadratic formula with some of these, that would be a very nasty question.
Anyway, let's bring the 12x over here, because we need to bring everything over on one side and put it in the proper order to factor. Like so. It's a trinomial. X minus 14, x plus 2.
Yeah, 7 and 4 won't work in this one, unfortunately. Remember, we're not done. We actually have to solve these things. And how do we solve? We make each factor equal to 0 and find x. So x equals 14. Negative 2. Okay, this one here. It's a pretty big one. What do you want to do first? Yeah, we got to factor that first. Denominator. The other ones are okay. Now? NPVs. Or I start getting rid of things, and they are positive 2 and negative 2. What do I have to multiply everything by? X plus 2, x minus 2, right? That's the LCD. So this is going to be a long step. So x plus 2, x minus 2 times this first fraction equals x plus 2 times x minus 2 times this one plus one more time x plus 2 times x minus 2 times the last fraction. So you see these things can get a little big. Okay, let's start canceling out everything. What can I cancel out of here? Everything. So I'm left with just 1.
Here, the x plus 2, so I'm left with 2 times x minus 2. 2x minus 4. Here, and I've got, remember, watch out for this, especially if this is negative, because that will change in the sign and multiplication, but it doesn't this time. So plus 1 times this, x plus 2. No x squared, so we don't have a quadratic. So it's pretty straightforward to solve, and just check to make sure it's not an NTD. Well, I can simplify the right, so I get 3x minus 2. The x is already on the right, so I'm going to move the minus 2 over to get 3 plus 3x. Divide both sides by 3. X is equal to 1. Double check. It's not an NPV, therefore it's good. Okay. Okay, next class we'll finish the next page, but just as a reminder, or just to let you know, take that out.
On the last page. We're not going to worry about that.
Okay.
So we've done enough questions that you should be able to start working through exercise 5.4. But I still, yeah, it's, we've still got a couple of questions to finish. We'll do that next class, like I said, but at least this gets you a chance to get started on exercise 5.4 to get some practice with these ones. Okay.